Hello, I'm Chris. Dimitri has kindly asked me to join him for some pair programming, I guess.
Using Sentient programming language.
Yes, so maybe we should start by explaining a bit what Sentient is. Just Sentient is a rather grandiosely named language that it's a bit of a toy language that I wrote a couple of years ago. It's specifically designed to solve constraint-based problems, so things that have a well-defined set of constraints, and you'll see hopefully what that means in a couple of examples that we'll work through today.
Yeah, so just in case, this is the Sentient website, and it has introduction and lots of other great documentation.
Yeah, I've tried to put some of my rationale on here, as well as these little interactive demos.
Examples and so on.
Yeah. But I think for the purposes of this video, we should just almost go from scratch and work our way up to some interesting problems.
Yeah, so I'll switch to some text editor.
Yeah, a really clean blank slate.
Just type something. So what's the minimal program we can write? Is it?
So it's probably if we just... Interestingly, Sentient doesn't really have strings, which is very unusual for a programming language. It's really a kind of logic-based language. So the program I usually do as a kind of hello world is finding two numbers that sum to 10.
So just realize that maybe even more minimal one is to have like one variable and expose it. So,
yeah. Okay.
And int a means what you think, I guess. You would think is that this is an int, and then expose means that it will be part of the output of the program.
Yeah, it's kind of like the version of logging some output is to expose the variable.
And we can add this shebang thing to make sure it prints something out.
Sure.
So I can, maybe a better example would be to run Sentient and then the file examples.
Yeah.
That's the canonical way to run it, right?
Sure.
For that, we don't even need shebang. And then it just prints a equals 0.
Yeah.
So that's, I guess, the minimal thing you can do.
I guess so. The interesting thing here, I guess, is that we haven't actually assigned a value to A. In a more conventional programming language,
you would do that.
You'd do something like that, right? But here it's almost as though A is uninitialized, or we haven't given it a value yet.
Yeah, and that's not going to work, right? Because you don't assign, you just specify constraints and Sentient.
You can do that as well, and that will like override the value.
Oh, really?
Okay.
I thought I thought if you expose, you cannot like specify explicit output, but I guess I'm wrong.
You can try.
Oh yeah, it works. Yeah, interesting. But then maybe more interesting things to do something like this, but a greater than 100.
Yeah,
that's maybe a better way. Then around this is just not 0.
And so Sentient will try and find a solution to these invariants, these constraints. And you might ask, like, what's the significance of 124? And there isn't really any. It just so happens that the engine behind Sentient has kind of settled on that value. And Sentient has lots of different options you can provide. So if you want to, you can say, like, give me 5 different solutions. So maybe if we run that with the -- number option, it will just spit out all these solutions. And they're not even in ascending order. They're just kind of a almost random seeming set.
But that's also like super simple example, maybe what you said, like with 3 variables. Or...
Sure. Let's do 3 variables that sum to 10.
Oh, okay. If you want to go like that.
Sure. I'll try and use your keyboard and so on. It's equal to 10.
Then we need to expose ABC, right?
Yeah. And then how do I run this?
Just F12, option F12.
F12, and then I guess we can have 5 solutions.
Yeah, there's just some numbers which I don't.
Okay. And then the other thing, so like this is a relatively simple program, and you could, in a conventional programming language, you could probably write something to do that quite easily. But the other interesting thing here is that you can make it even more generic in that if you wanted to, this 10 value, you could make another integer in this program.
Be a multiplied by b. Is that
well, you could do that. So you could say a times b here.
Yeah, I don't know if that's going to work at all. Right?
There may be no solutions. There may be some.
There are some.
There are some. But the thing I was also going to suggest is you could introduce a new variable for this, like the target that you want these numbers to sum to. And then the interesting thing about exposing variables is it not only lets you see their values, so like it's printing them out here, but it also lets you assign them. So you could say assign, and then this takes like a little chunk of JSON. It seems like the simplest way I could get to read these values in. So if we here we wanted to assign a value of 10, we could do that, but this is like a single program now that we can dynamically plug in different values at runtime, which is quite nice. Okay, so should we maybe try adding some extra invariants or playing a bit more with the language?
Yeah, maybe something less trivial, something more realistic. Let me close this thing.
So you saw a tweet. Do you want to try that example?
Yeah. So there was this tweet by Robin Houston. So it says, there is an anagram whose square is an anagram of like, there's an anagram of 1, 2, 3, 4, 5, whose square is an anagram of like this other number 1 to 9. Right. So I'll just copy paste it into here to make sure we have it.
Okay.
And do this. So yeah.
So I guess the first thing to point out is if we wanted to, in a conventional programming language, we could write an imperative style program that starts from 0 and counts up and like tests all of the numbers up to 99999 and like squares them and then sees if
they have to be an anagram of this as well, right? You get through all the numbers, then exclude those which are not an anagram.
Yeah.
The number is going to be like lots of division, mod things. It's going to be tough, I'm sure.
Yeah. So hopefully we can solve this in a more declarative way. We can, instead of thinking about like what kind of algorithm would we write to solve this, we can focus more on like how do we describe this problem to
like
the
what
machine.
The problem is, right? Instead of how to solve this.
Yeah.
So how would you represent an anagram? I guess it's as an array.
Yeah.
There are arrays in array of size 5.
So in Sentient, arrays have like fixed size. Yeah.
That's anagram 1.
Yeah.
There will be anagram 2, which is 9.
9.
Things.
Sure.
Yeah. Then there is also in different type of ints. That's the default platform int, but you can specify how many bits it has. I think 5 might be good. Will be within the range, or even 4. No, I guess we have numbers from 1 to 9, and 2 power 4 is only 8.
Yeah, I mean, maybe this is too much detail at this stage.
I'll go back to normal int. Sorry.
but you're absolutely right. So the underlying thing here is that everything in Sentient has to be like of fixed size. You can't have infinite, and that's true in a lot of cases in computers. If you're working in C, you usually have to specify an integer as like 32 bits or 64 bits, even though you don't necessarily have to think about that.
So we could even run this thing. Already, let's just say.
I think that's useful to like periodically run it and just
like
check.
Incremental, so you see syntax is correct.
And
that's an anagram. It's like all zeros. Well, that's an answer.
That is an answer. So maybe the first thing we should do is add some constraints that these numbers are within those like between 1 to 5.
Right. So, maybe the other thing you could go anagram and do each. This takes a function.
Yeah.
And this will take a digit.
Yeah. But then, okay.
And then can have invariant that this digit is between. Well, I can write it like this. It's like greater than or equals to 1 and digit greater than equals to 1.
Sure.
That's one way to do it.
Yeah.
Maybe there is a better way.
So the way you've written this constraint will make it so that every digit is between 1 and 9.
Yes.
But it won't add this more global property that you can't have repeated digits.
Yeah.
So I'd probably write this a little bit differently.
Yeah, sure.
Which would be to say, I'd go from 1 up to 5. So a lot of Sentient's syntax and the methods that I've implemented in like the standard library is quite similar to Ruby. It has a slight JavaScript feel.
Yeah. To be clear, this each is just not JavaScript or anything. It's part of Sentient library.
Yes.
And this function is not JavaScript function at all. It's just Sentient function, which looks a bit like JavaScript.
Yeah. And actually, you can tell it's this language I kind of wrote before a lot of the newer JavaScript syntax came out, so it doesn't have like the more terse versions of function definitions.
It shouldn't be too hard to do that, right?
No,
I'll send a pull request.
I haven't really touched the language in a while, but it could probably benefit from a bit of a stylistic revamp. So what I would probably do here is say 1 up to 5, and then this takes a function, I think, which gets past each of those digits.
It's 1 to 5 inclusive.
And then we could say...
Oh, right. I also did 1 to 9, which is incorrect.
Yeah, because this first one is just 1 to 5.
Yeah,
right?
yeah.
So we want an invariant that anagram 1 include n, I think. And then let's just drop that for the moment.
Yeah, no, let's drop it forever.
And then, can we run this?
Option F12.
Option F12. Anagram 1 must be declared.
Oh, well, that's an interesting thing.
This is, yes. So a slight quirk of how I define how functions work in this language is I made their scope quite locked down. So at the moment, this function can't see anagram 1, which is declared outside.
Yeah. I'm not sure is it because of some optimization or not, but even if it's not actually like this feature, because it's easier to read functions, you definitely know that like this function never looks outside of its scope.
I can't remember my rationale for doing that, but I like things to be quite quite locked down. Less global scope is good, I think.
So you use this hat.
This hat basically means that you can look up higher above the current lexical scope. I don't know if this has like a programming language theory name, but
you will set the trend. You will see languages using this hats everywhere.
Maybe. Okay, but the good thing is we can see here in this output that anagram 1 now has the numbers.
Do you mind if I write the second one?
Sure, go for it.
Just to copy.
You've already got the hang of it.
Ta-da! Still just some anagrams. They don't follow the constraint.
Yeah. So now we need to add in another constraint which has this property that connects the two anagrams together. And to do that, it's not immediately obvious how, because these are currently arrays of digits. They're not actually numbers. So if we want to perform a numeric operation like squaring one of them, it's like tricky to do that.
Well, it shouldn't be just iterate, multiply by 10, something like that.
Right. So we need a way of going from an array to a decimal version of that array.
Yeah.
So let's try that. if I can remember
Yeah.
all the right things. So Sentient has a function called reduce, which is also sometimes called inject.
But I mean, just to start with, we can just define a normal function and call it to number. Right?
Yeah,
and this will take an anagram. That's like the basics of this, right?
Sure.
And then it will, return something. I don't know what. So we need to do something here. So that's like the shape of what we want to do.
Right.
Right. And then we go through anagram. And then you're saying there is reduce function.
Yeah, so we can convert an array to a decimal number by doing as you suggest and like compounding it by 10 each time.
And reduce will take what, the first number? Does it take that? Is it like fold?
It will, if you don't give it the first like an accumulator number, then it'll take the first one, I think.
Right. But should we go with 0? I think. If you want to type.
I think I can't remember. Let's try.
Okay. I'll do the typing so you can think.
All right. Let's do that.
So I'll call it 10 for consistency. So it actually is just a digit, right? It's like n sounds a bit like number, and we convert into number. That's why it's not n, it's digit, but fine.
Yeah.
So we have n, and this returns something.
Yeah. So this function actually gets passed 2 arguments. One is the it takes the accumulator and the current digit.
Oh, without index, so that's accumulator and n.
Yeah.
So we want to return accumulator plus something, for sure.
Yeah. So the accumulator will actually multiply by 10 each time.
Oh yeah, we go left to right. So the first time we take 1. Then we multiply 1 by 10, this becomes 10. 10. And we add 2.
Add 2.
Yeah, that's like that. Right?
I think so.
This looks reasonable.
And maybe we should even just test this 2-number function by itself. Well, we could comment out this first chunk
at the beginning.
And then construct an array of like 1, 2, 3 and call that function on it.
3, and then what do we do? Map?
This takes an array. It takes an anagram. So you'd call 2-number with this as its argument.
Oh, sorry.
Oops. So it would be like 2-number with the array.
Oh, yeah. But it should be array of 5, right? 1, 2, 3, 4, 5.
Well, it could be. I just want to test this 2-number function, basically. Yeah, so let's call that like x, and then expose.
That's how you debug in Sentient.
Yeah, I mean, it's a very lightweight way of just checking.
I didn't know that was the way.
How do I?
I'll do it.
Okay.
Then we can do this. Doesn't like unexpected x.
Slight quirk of the syntax is you need semicolons after function definitions. It just made the syntax parser a lot easier.
No, it makes perfect sense. That looks fine,
so that is working. Cool.
Yeah. What if we have zeros? That's gonna break. But that no, it won't.
It should.
I think it works.
It should work.
Wait,
yeah,
it did work. That's cool. Yeah,
cool.
So it all looks promising.
And
I'll get it back right.
Yeah. Okay. Well, let's bring all that back in.
Then we want to add some constraints in this, right?
Yeah. So if we go back to our original problem.
Yeah, so it was like this anagram whose square, so we can have anagram to number, anagram 1.
Yeah.
And it should be
so we need to square
that. Is there a square function?
There is a square function.
So just that equals to number, anagram 2.
Yeah.
And that's it.
I think so.
Wow, okay. That's cool. I think I need to move this because 2-number has to be defined before it's used. From what I remember.
That's true, yes. There is a trick around that.
Should I run it?
Yeah, let's try it.
I think it takes a little while to run.
Okay.
Last time I tried. But then also, like this 2-number, which I really like, I'll do some refactoring while it's running, that you can do this because it's the only argument. I really like this thing.
Yes.
So basically you can do this with your first argument with any function. Right?
Yeah, so
It just doesn't.
yeah, I kind of took that inspiration from Python, where
Mhm.
the first argument is like self, and that means you could then call that function on that thing, and it passes the thing you've called it on as the first argument to the function. And Sentient is quite dynamic. It doesn't really have much of a type system. So as soon as you define a function, you can just call it on anything, and you don't even need parentheses. It just figures it out. All right, that has given us an answer, but is it correct? Should we actually, well, if we like use the calculator on the map? Okay, yeah.
What did it? 1, 2, 3. Oh wait, 1, 2, 5.
5, 4, 3.
Square.
Yeah.
Run.
Yeah. And we get that number.
Yeah.
So that seems good.
Yeah, that's awesome. I think it took a while to run, but this was because I think, as I understand, the way Sentient works, like, converts everything to some other representation, which can then be executed in different engines or like solvers. Right?
Yeah. So the back end of Sentient is it uses these things called Boolean satisfiability solvers. It basically takes this program and it turns it into something called the Boolean satisfiability problem, which is like a massive Boolean equation that is often, it was I think it's the first problem that was proven NP complete. So it's like a really good canonical problem to turn other things into, because there are these really
all NP complete problems, they try to convert themselves into this problem, and then there are engines which do it very well, right?
Yeah, it's called a reduction when you turn a problem into another problem.
Yeah. And I think in this case, what I was trying to say is that it was kind of slow because it was just a default engine in JavaScript, which doesn't run that fast.
Yes.
So there are better solvers which will run it much faster. Right?
Yeah, it's probably worth noting that this Sentient is actually written in JavaScript, and one of my motivations for doing that was so you can run all this stuff in the web.
Oh, so you were showing
yeah, so
that's Sentient website, right? And it imports Sentient JavaScript, has JavaScript things in it.
Yeah, so it has this Sentient package.
The whole environment, right?
The entire environment.
Oh, wow.
So you can compile programs, you can run them. So we could actually, if we wanted, take this whole program.
If you feel like doing it, sure.
I'm feeling brave. So let's say...
This is magic. Anyone in the world can go to this website and solve the...
in their browser?
Yeah.
Oh, except maybe... Does it support the multi-line?
To escape things, unfortunately.
I don't know. Does it support multi-line strings? It looks like it. Yeah, so we could say Sentient compile program, which is just a string.
Yeah.
Oh. Maybe that. I don't know what's going on there.
Yeah, it's not obvious. Maybe do hello world and stuff.
Yeah. Oh.
So it did compile.
I'm not sure why that didn't work.
Yeah, well, it's like...
but yeah, then we could take that as our compiled program and then run it. So sentient.run with program is compiled program. And that will then give us an array of solutions. In the default case, it just gives us 1 when A is 0, but we could say, give me a number of solutions.
Yeah, cool.
So it should be the same environment. I'm not sure why that didn't work, but
I think this is so cool. I have a feature request. I wish this website just contained an editor with syntax.
Maybe it should.
It just would be so cool for demos too.
I put these little examples on here which are interactive in different ways. But maybe I should like make them more editable as well.
Well, this is great. I mean, I really like this, like H greens on Nitro is the best. I think it's so interactive. It's like there is a solution. Nice to.
Yeah, it's actually like solving that solution right now.
Oh,
when you visit the page.
Why don't we jump? Oh, yeah. Now it actually shows the actual one of the solutions.
Yeah, it's when you click on it, it like goes to the next solution.
So there are lots of interactive things already. So.
Yeah, but I was keen that this Sentient website actually solves these problems live. Yeah. Because I kind of wanted to show the power of like this thing is running in a browser.
I want like additional like live coding
online.
Maybe I should sell a pull request. It's all open source, right? It's all MIT licensed.
Yeah. I won't stop you from opening that pull request. I might not do it myself, but I might. I think it would be a nice feature. I even wrote this little syntax highlighter for the language. Maybe it needs an IntelliJ one as well.
Should we wrap up here?
Yeah,
cool. Thank you for your introduction to Sentient.
My pleasure.
The tricks.
Cool. Right. Thank you for having me on.